Arden, who did a lot of this work together with me, and also my former student Mo Akade, who did a lot of the literature review on the paper that you see on the proceedings. So this is probably one of the first, if not the first, physical computing and robotic device ever created, and this is the floor turtle that Seymour Papert and his team used to use with kids, and it would draw pictures on the floor, and kids would program it. So that's the famous floor turtle. But we've come a long way since then, and now, in the 80s, we're using, C-like programming languages to program, and then we moved to this BASIC-like language, which was, that was a device called Basic Stamp in the 90s. And then we moved to Logo in the 2000s, and which is a lot easier to use, as you can see. It's a lot simpler and all of that. So, a pretty interesting evolution. Oh, sorry. Oh, it's actually the other way around. We started with Logo in the 80s, and then we moved to the Basic Stamp. And now we are doing C programming with kids. And so this talk is about why the heck this happened. And not only that, but we also, in order to make 2 LEDs blink, we make kids deal with 9 wires, 3 resistors, a breadboard, and on top of the LEDs and all of that. So this is a review paper, and so my talk is about the history of these devices and how it came to be that, instead of kids programming using Logo, they are programming using C and other questions like that. And I use 2 analytical constructs that I have in the paper. One is called selective exposure, which is what is backgrounded and foregrounded in hardware and software design. So what kind of things do you hide from the user on purpose, explicitly? For example, maybe the polarity of your motors, or the way you connect the sensors. You don't want them to use resistors, or you want to do something at the programming language level as well. So how designers select what they want to expose, and self-error correction, which is how the material communicate the rules and the best practices for construction. So the best example of this is a Lego. So Lego, it self-corrects. It has built-in error correction. So there are only certain ways you can build Lego. So you and the material, you're a better builder with Lego than without. So it helps you build, and the material communicates to you the norms of construction. So those are 2 criteria that I use to evaluate those designs. And so let's go back in history many, many years, 30 years ago, when the MIT team was creating this device, the MIT programmable brick, the red brick. And here you can start seeing what these issues of selective exposure and all of that. So the connectors that they designed for the sensors and the